Hello everyone, my name is Nannaphat Supaseranee from Rajasima Vidyalaya School, Thailand. I'm proud to present my physics project in the 9th Asia Pacific Conference of Young Scientists, or APCYS 2020. The title of the project is Dimensional Evolution of the Lost PLA Aluminum Casting, which is under Dr. Saram Bunmi from Supaseranee University of Technology. My talk is divided into 5 parts. The first part is introduction, about metal casting by lost wax and lost PLA process. The second part is objective and scope. The third part is methodology. Results and discussion are in the fourth part, and followed by the last part, conclusion. Now let's start with the first part of our talk, introduction. What is lost wax and lost PLA casting? Both are investment casting which create a metal part from lost pattern that also have an opening tube for input liquid metal called gating. There are 2 necessary steps to make mold: design pattern and mold making. In this work, we create lost pattern in cylinder shape, then covered by a cement or fire resistance material which has a flowability to follow the specific shape. In this step, we do it twice to increase the strength of the mold. This slide shows of lost wax process. After the covered mold is burnt, the molten wax flow out through gating, which allow the mold to have a blank vacancy as needed. After burnout, pour liquid metal in mold. Wait until the casting set up and cool down. Then, knock out the mold and cut the gate off to get the precise metal casting. In this work, we have used PLA instead of wax. So, here's PLA's detail. PLA, or polylactic acid, is a thermoplastic polyester with backbone formula. The monomer is typically made from the fermented plant starch, such as from corn, cassava, or sugarcane. PLA is the most widely used plastic filament material in 3D printing. The method of lost PLA casting is the same as lost wax casting, but we use PLA as a lost pattern, as shown in this slide. Lost wax and lost PLA has the same procedure. Here's the reason to use PLA instead of wax in our project. The combustion effect of wax, which is a mixture substance, often causes pollution and leaf ash. But the combustion effects of PLA, which is a pure substance, after burning, the PLA will sublimate into vapor, no residues. So it's better to use PLA. In terms of convenience and safety, lost wax casting are often used on workpieces by people that do not require much detail and have a long process. But lost PLA casting has a shortened process and get more detailed and accurate workpieces from machine. At present, the process to create artificial bone is milling that consumes a lot of time and have a very high cost. In order to create low-cost, personalized product for everyone, this following 6 steps procedures was proposed: scanning, drawing, 3D printing, molding, casting, finishing, and assembly. In this work, the 3D printing material was PLA, and aluminum was a representative metal for casting. Naturally, when material transfers from liquid to solid, the dimension is changed. So, to get the personalized product, we have to know how much dimension allowance in this method. Therefore, our objectives are to determine dimension allowance of the casting method, which consists of the dimension allowance of 3D modeling and the dimension allowance of the casting. In this experiment, we will use aluminum grade ADC12 because we want to know only the phenomena and the possible of this process. Now we are here in the third part of our talk, methodology. Start with decide the desired shape in 3D modeling program. Generally, the cylinder shape was used because it's easy to print and measure on X, Y, and Z axis. Then set the dimension at 25 millimeters on each X, Y, and Z axis. So we decide gating to get 6 aluminum samples in one set of casting. This slide shows aluminum sample production process. First, use SolidWorks, the 3D modeling program, to draw and resize, then print it and make mold. Finally, make a casting and finishing it. For dimension measurement, we use vernier caliper to measure on X, Y, and Z axis of the sample. The X, Y, and Z axis is shown in the animation, and we measure the sample in 2 steps. First, measure the PLA model before casting, and then measure the casting part after casting. Okay, we arrived at the part of results and rechecking. Let's look at the PLA model first. The graph showed that the dimension of the model increased beyond 25 millimeters. It means that the PLA model has expanded from drawing. And for the casting part, the graph showed that the dimension of the casting are less than 25 millimeters. It means that the casting part has shrunk from drawing. In the process of rechecking the results, linear displacements and cooling curve method were used. This equipment and graph show that when aluminum changed from liquid to solid, the aluminum had shrunk with time. From the measurement table, the PLA model has expanded by 0.3 millimeters from drawing, and the casting part had shrunk by 0.45 millimeters. It was found that the dimension of the 3D modeling decreased from drawing, and the dimension of the casting increased from drawing. Here's an explanation. Let's look at the 3D printer nozzle. We draw a circle in the program, then print by 3D printer. The printing line was wider than the drawing line, 0.3 millimeters. Therefore, we have to allow the dimension of 3D modeling decrease by 0.3 millimeters. In order to find that is the expansion constant for every dimension or not, we draw different shapes, print it, and measure the diameters, and plot the results in graph. And it was found that the model with different shape showed a similar expansion of 0.3 millimeters from drawing. In the casting part, the allowed dimension increased by 0.14 millimeters from drawing, because the workpiece had shrunk from the solidification of the metal. In summary, the dimension change of the workpiece consists of the expansion from drawing process to PLA model, and shrinkage from PLA model to the casting part. The expansion of 3D printing process was constant at 0.3 millimeters, and the tolerance of the aluminum shrinkage was 1.78%. This result lets us prove the allowance equation as shown. This equation will be useful for those who wish to create a personalized metal casting fitted to their purpose. These are examples of workpieces that we have created by using lost PLA process with the allowance dimension for the precise artificial bone. Finally, I would like to thank all the support from the Ministry of Higher Education, Science, Research and Innovation. And special thanks for APCYS committee to provide young students like me to having opportunity to showcase my research finding to everyone. Thank you for your kindly attention. and I will be glad to hear any question you may have.